I'm going to hit record this meeting and I'll share my screen. There's my baby. Let me pull up my everything that I've got going on today. So if I go into Blackboard and class sessions, we are in class session 11. Scroll, scroll, scroll. All right, so the emphasis is on HVAC this week. Emily's so excited. All right, so we have required reading is going to be 12, 13, and 14, right? We did some further on chapters last week. We're kind of flipping it around based on priority. And then we have an assignment that is lighting calculations. And then I gave a IESMA more detail, and that will just relate back to the lighting calculations document that's attached to your homework. So how many fixtures are required? I've included a few diagrams for you, and that I've already gone through and rotated. You'll understand why in a minute. So I had some help here, I'll call it help, scanning some stuff, but it wasn't very successful. So I will be posting the chapter. It's just not, it got done today, right before this class, we'll say, and you'll see. So we're going to review that packet during class so that it's less confusing. I know some of us struggle to have digital PDFs of books already, but I think that I've kind of tapered it down so you only have to focus on certain pages. Writing assignment for this week, so cheat sheet continued. Add to your cheat sheet that you started last week. This week, focus on HVAC codes. What are the ASHRAE codes of most importance according to the book? Look up the actual codes. Do not simply give me the number for the standard. That'll make sense when you find the keyword ASHRAE codes in this week's reading. What are comfortable room air temperatures? What is the IECC code requirement? Might go a step further and include the IRC. So the only reason I separated those and said you might include the IRC is I'm more concerned with the commercial codes than I am with the residential, but it's your cheat sheet and why not have the residential? We do have some more residential projects given your placement in the program, so you might as well have them. What is the average distance between diffusers and registers or grills? Contract focus, so I'm not concerned about this in a residential setting. Supply, return. This is not found in your book. So there's diagrams that relate to this, but the distances between them that you might use if you're responsible for creating a reflected ceiling plan, that's not specifically spelled out. The best ideas, I say the best type of research is finding a contract space or commercial space like Ivy Tech and counting the ceiling tiles between diffusers and registers or grills. Visit a couple areas. How do these distances compare? Tell me the building you chose. Take pictures of your ceiling to prove your visit and the distances. You could also do research online of reflected ceilings with HVAC. Do your best and we will discuss your findings on this one. So it's going to vary depending on which buildings you choose to visit, but they cannot be residential buildings. And if you're already at Ivy Tech, you might as well take the time to use our ceilings as an example. It's a quick, easy fix. For those of you who aren't here, you could go anywhere really with a focus on ceilings that have ceiling tiles to be able to count them and see those distances. And we'll look at a few images tonight that will help support the ideas we're getting across. So below that, I have a few links, HVAC plan examples, and fun exposed HVAC. See what is hiding above the ceiling. So we're going to go ahead and get started, and I'm going to do something a little strange. So later on tonight, I will be posting your quiz links, or turning them on really, and then it's really just one link, 3 quizzes for the 3 chapters that you have to read. It'll be similar to last week's layout. And then I will also be posting 3 PowerPoints. So I showed you, I think, last week that there's these preset PowerPoints. I can pull one up, where I add images and text to them, but they have this very texty look to them at first, unless I add any of the images. And there's just too much to cover in the amount of time that we have. I'd rather work together on some of these math calculations in class than get too concerned with all of the details on thermal heating, which I feel we did kind of cover when we had the wrong book in the wrong chapters. They had thrown some of that stuff about the envelope and energy savings into the beginning part. So some of it will be new, but I don't think anything that we're not covering today is something you couldn't discover by reading for yourself. If you have any questions on the reading, then you can ask me personally via email and I will help explain it to you further. So I am going to give you all of the PowerPoints with the focused knowledge areas for the week, topics for discussion and study, and then a little introduction history, and it has all the nice charts that are easy for you to copy and paste or use if you want to. That's a hint. Use them for your cheat sheets. Screenshot them. If you're like me, you screenshot everything. Drives my husband crazy. So each of these slides will help you. And really, I think the most use for us is just the charts for this week. So going forward, things that we definitely need to hold on to outside of principles of sustainability that I feel they do a good job introducing. So these will be posted, all 3 of these, and I've added some images here that we'll talk about. But I want to start actually with the lining portion of it, as that's more of what's going to show up on your final. And we are in week 11, oh my gosh. So let's go ahead and look at your lighting homework. And I think it's how many fixtures are required. If you open that up, here is what it looks like. So like I said, I've provided you some charts that look like this. Lighting design basics, here's that catchphrase here, the little shortening of the IESNA. It says categorizes light level criterion recommendations based on 3 aspects: complexity and difficulty of visual tasks being performed in space, the priority of the task relative to others, and the age of the user. The categories are category A, public spaces, and here we see it's 3-foot candles for public spaces. Category B, simple orientation, 5-foot candles. Category C, simple visual tasks, 10-foot candles. Category D, tasks of high contrast and large size, 30-foot candles. Category E, tasks of high contrast and small size, 50-foot candles. Category F, tasks of low contrast and small size, 100-foot candles. And category G, visual tasks near threshold up to 1,000-foot candles. And we're more concerned with foot candles than the European version, which is Lux. All right, so it says for these light level recommendations, it is assumed that more than 50% of the occupants are between ages 25 and 65. If more than 50% of the users are over 65, it's generally recommended that the light levels be doubled to compensate for their aging visual systems. In addition, as expected, if more than 50% of the users are under the age of 25, the levels can be halved. To choose an appropriate level for each visual task, use these values or refer to the IESNA Lighting Handbook, 10th edition, for further explanation. Here are points to remember about recommended criterion of illumination levels. These are recommendations, not codes. However, specific lighting levels may be set by codes, such as Life Safety Code, Health Code, for instance, NFPA 101 specifies that 1-foot candle 10 lux minimum along a path of emergency egress, which we'll see tonight when we kind of look at our final layout. The designer is expected to adjust the criterion level based on project needs. For example, if workers are old, the tasks are small, or the tasks involve low contrast, the designer may choose to set a higher level. The design criterion chosen is an average light level for task lighting. Some tasks may be lower or some higher. And then they have more information, but I'm mostly concerned with those first couple of paragraphs. So referring back to our class session and what I've given you, so we see IESNA more detail. If you click on this link, I think this is just outstanding. Will it be extremely helpful to you? I think if you're willing to do the work on it, it would be, but all I'm going to need for your final is the basic. I just wanted you to see how much thought goes into evaluating light levels given the situations. They have worked through everything you could ever imagine, all right? So here we have orientation and simple visual tasks. Visual performance is largely unimportant. These tasks are found in public spaces where reading and visual inspection are only occasionally performed. Higher levels are recommended. So we see public spaces, simple orientation for short visits, working spaces where simple visual tasks are performed. So there's way more levels associated with the different categories. And then they've broken it down by this lighting design guide. So interior locations and tasks. Accounting, air terminals, armories, art galleries, auditoriums, banks, we keep going, casinos and gambling. And then for the casino and gambling, they have the circulation area, if you're playing bingo, blackjack, keno. So they really thought this through, I think. Churches and synagogues right after, of course, the casino, because those two go together. And then club and lodge rooms, conference rooms. Then we have correctional facilities, courtrooms. Here we have drafting graphic arts, so this might be important when we're building our CAD stations for future designers. And then we have these color coordinations that say if it requires a higher level or less of a light level. So there's much more detail outside of those basic recommendations. And then I think we have even yet a clearer chart that for basic recommendations we can use towards our final chart of calculations. But I think it's almost amazing how many subcategories they've broken it down into. Radiation therapy, solarium, hotels, libraries, just amazing. All right, so this is available to you, although not necessary for your final project. Let's go back to here so that it's ready for us, and then we'll get back to our actual homework. So let's scroll down a little bit more. Rough calculations for architects and interior designers. While it is no longer common for architects and designers to calculate lighting levels, it is very common that they produce basic lighting designs and perform lighting layouts. The following methods can be used with reasonable accuracy. Remember, however, these methods are only estimates and do not replace accurate calculations when they are called for. The watts per square foot method. I think this will be the one that you will most often, if not always, be using for your final project. This method works well for many space types. Simply multiply the room area in the square feet by watts per foot using table 8.1. Area by watts per square foot equals total wattage. This will tell you how many watts of either fluorescent or halogen sources you need to achieve recommended average lighting levels. By the way, the table is intended to work in conjunction with all North American energy codes as of January 2000, but other restrictions may further affect your designs. This method works especially well if you follow these rules. Apply only to relatively ordinary spaces with white ceilings, medium tone to light walls, reasonable number of windows. This method does not work well for dark colored spaces or spaces with unusual shapes. All right. Here we have our watts per square foot chart. So here it's telling us the different types of areas we might be encountering, average light level desired for those typical applications. So for a hotel, we might want anywhere from 2 corridors, let me specify in stair towers, 2.5 to 5 foot candles. For office corridor, parking garage, or theater, we might have 5 to 10 foot candles. For building lobbies, and so on and so forth. So we have our average light level desired and typical application. Then the next column we have watts per square foot of fluorescent, compact, fluorescent, or HID lamps. And then the last category, we have watts per square foot of incandescent or halogen lamps. And then we have some non-recommended. Okay, so there's all the charts we have going towards our formulas. And then here's the actual equations I'm asking for. But let me open up, and I will be posting this. So I just pulled out some of these charts so they're easier for you to read. Let me open up the actual document that I had scanned in today. Okay, that's not so bad, right? So here is an example. So an area of 800 square feet, and you have to know these things. There's some things that we have to know in order to use this watts per square foot method of solving how many fixtures are needed for a room. So for your final assignment, you're working on in Revit. I saw today you were kind of breaking it down by areas, right? Offices versus kitchen or whatever areas that you have, right? So in those areas, you hopefully know the square foot by the time that you're done with your project. So for my friends who do not have a Revit project, if we have a project we're going to use or an old project we need a core for, your first step is going to be to measure the area of each of the individual rooms. That will be given though. We have our core, we have the area of the rooms. So it's given, you just have to measure for it. So let's assume that we have an area of 800 square feet. We have to have the average foot candle level required. So that was when we were looking at the criteria required for a task, that kind of looser version, but it's also given in, if we come back up to our chart up here, oh, I'm not in my fancy document that I made for you. So here's the loose definitions by task, how many foot candles, but also in this chart down here, we see it's 5 to 10 foot candles for offices, corridors, parking. So let's go back to our book. So we have to know what kind of area, right? So if it's an open office, which some of you have, you're working, that's a given. You know what kind of area it is. Hopefully, is it a bathroom, a hallway, an office? We know the given overall area in square feet. In the case of the book, it's 800. I'll get back to that example. The foot candle level required is based on what type of area. So in this case, it was 50 because it was a classroom. And that was going back to that chart. Now I want to say something about the chart. Did you notice that there, oh, this is going to get annoying. Did you notice that there are ranges given? Okay, so 20 to 50 foot candles. You are allowed for your homework, because it does vary by in this range. It could be anything in between those values. So if you want to just give me the range 20 to 50, that would be okay, except we have to finish out our equation. So I'd like you to pick a value within there once you've decided on what area it is. And it says classroom, right? So 50 makes sense why they chose that. It was in the range. I've been going with just the highest value, but I do ask you to justify why you chose your value within your answer. So you would say chart 8.1 says that the range is 20 to 50 and my number falls within that range, and I'll check your answer that way. Okay, so 50 because it's a classroom. We know it because of its location and type. And then watts per square foot from chart. So we have that it's 1.2, given that it's the foot candle level required is 50. So if I look at my chart, and really the charts are all in here too. I was just trying to give you another document that they're organized. So in here, here's that 1.2. So highest version of the range. They took, if it's 50, then we're going to get a correlating value of 1.2, right? So it's all making sense. We have a lot of givens with our chart. So we're opening it back up again. Fixture selected. There's direct, indirect fluorescent pendant with two 32 watt, 4 foot long T8 lamps. And we can get to the image. It's just going to give you a visual on it. But for now, let's just think of this. So we have, if you imagine a pendant lamp that has 2 bulbs within it, and there's a little image of it like this, the end elevation of the lamp. So here's a bulb on the screen, and then here's another bulb. So there's 2 per fixture. We have to take that into account. It's not just one lamp. And then each of those bulbs is 32 watts. So what we end up doing is we take our area, which was given, we had it already, 800 feet, times the watts per square foot, which we got from the chart after figuring out the foot candle level required. And that gives us 960 watts that are needed overall for that area. Okay, well then we need to take the overall watts that are needed and we need to divide it by what we have given our light fixture. So I have 32 watt bulbs and I have 2 per fixture. So I'm going to take this information and multiply it out, take the 960 and divide by it because that gives me how many watts per fixture, and that gives me 15 fixtures required total. Because I have my watts needed for the overall area, I have how many watts are given per each of my fixtures. I just take watts per area divided by watts per fixture and it gives me fixtures required. Does that make sense to everybody? Or at least enough sense that you feel like it's not going to be awful when we go to do the homework. I'm trying not to surprise anyone. I'm trying to at least walk through and get questions today. Let's take a look at this, and maybe I can cheat the system and I'll screenshot this. Okay, so we can have it up at the same time as our next page. Okay, so you see the issue. Every other page is flipped, so you're going to have to rotate your view. And I'll do it one more time. Counterclockwise. Okay, so here's our classroom, right? And in our classroom, here's our fixture, which is nicely labeled F1. And within each of these fixtures, there's 2 bulbs. So a bulb on this side and a bulb on this side. That didn't help us with the overall layout, so that's just something that's an aesthetic thing and sometimes is based off of our existing HVAC plans. Hopefully we plan it all together at once so that it has a beautiful layout. It's kind of an artwork in itself. We'd have sprinklers up there. We'll have diffusers, returns, possibly exit signs. So just thinking about the fixtures, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, and then let's see if I can't have this open at the same time. Is somebody's phone going off or something in our class? Do you hear that? Is that real noise outside? All right. Sorry, guys. I'm just checking on something in the background here. Gotta move all my... Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it might have been, in this case, a decision that was made for aesthetics, I'm assuming. But this gives you an idea of that they added the 16th light, because it would have been uneven, and that might not have been a good design to just have an extra light at the front nearest our whiteboard and projection screen. But as far as finding it, you can better see the fixtures. So here's F1, they have them side by side, and then there's one side with one bulb and the other side with another bulb. But we had all of our givens, so this overall space supposedly they say is 800 square feet, and we would have that to start, just like you will for your final. We could figure out by what time of room it is that it was 50 foot candles necessary because I looked at my chart sorry. I'm distracted by the noise in the background. So it was a classroom which told me 50-foot candles needed. I chose this arbitrarily from this amount. I mean, it's always better to go with more than less most of the time. So I took the highest value based off of the classroom of foot candles needed. And then I also was able to have my 1.2 watts per square foot because it was the highest value that was pulled over from this column or from this row. So if I go back into my homework, does it make sense to you how they get this answer? And just a quick yes or no will suffice. We can go on to do more examples if it does not make sense. Yes, all right. Great. Of course it makes sense to my accountant friend. No, Omar. So Emily's question was, for your homework, are you going to have the information about what type of fixture it is, this 232 watt 4-foot long lamps given to you, as well as your square foot and the type of room that it is? The answer to that is, if we scroll down in our homework, I say, I give you the area, so an office corridor. I give you the square feet. And then I say, you provide the lighting fixture specs. Highlight the given watts and apply to the equation. So you get to pick out a fixture, and you can choose your source. It could be Y Lighting, or it could be Lighting Direct, or if you want to Google, Cheryl was saying it'd be good for people who are working on their Revit projects, different lighting companies that collaborate and have the Revit symbols already so that you're preparing yourself for your final. You could do that as well. Let's see what that looks like. I think I have an example open on here. If not, I can pull one up really quick. Well, let me open another tab because I have all my important tabs open. Y Lighting. All right, so here I have my lighting cube, and then I have a bunch of information on it. And here I have how many watts given the type of bulbs, and I have a choice in size of fixture, so my dimensions are going to determine what size my bulbs are. And then I'll have my manufacturer information specs, and it'll tell me the temperature of my light. Dun, 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 dun. And then it will also tell me the overall dimensions of my light. Now you're not doing any drawing for your homework. You're just plugging in variables into your equation. So you have fixture wattage for the 15-inch flush mount cube is your 43.2 watts, and then you have your fixture output in lumens is 2571. So you'll be able to pick and choose, and then you will just give me the spec sheet that you use to complete it and tell me which fixture and plug it in. Okay, so but I would recommend, you know, if you like a light fixture, it might be better to start, as I said, Googling in advance lighting sources that have Revit symbols. Or I don't know if you, I haven't done Revit in 10 years. That's literally how long it's been. So maybe there's a way to work backward, just like in AutoCAD, where you can select your lights from Revit and then follow that to the manufacturer site. I believe that's possible. They have a library. So that might be the better way to work through it. If you don't have Revit and we're going to be working with your core, it is just a Googleable, is that a word? Did I make it up? A Googleable thing that you can do, just like I did with Y Lighting. And then if you want it to have, you don't need it with the Revit symbol if you're not using Revit. So you would just record the dimensions, like if you're going to do it in AutoCAD, and that way you save the sheet and you know it's 11 inches by by, let's see, 11. And then when you go to draw it in AutoCAD, you'll give me this rectangle as your symbol and you'll put it into your legend. We'll talk more about reflected ceiling planes and how to do them later. But your wattage and your lumens, if we need them for a later part of this exercises, those are all found in your spec sheets. Okay. Placement. Yeah, Emily's saying, am I really concerned about the fixtures that you choose and making sure they're appropriate for your use towards your project right now? No, I'm not. I'm just trying to help you plan the best way you can in advance so you're not doing work twice. Because then you'll already have your calculations done for one of your fixtures. And in an office building where you're most likely going to have a lot of repeated fixtures like troughers and such, you might have, 25% of your work done. So it just, work smarter, not harder, right? Our favorite thing to say. All right, Omar, so let me see. I am going to give you the ridiculous book scanning that we have. So let's open it up. Can we redo this exercise together with a different idea without confusing anyway? Let's see. I think they actually have a different example. All right, so I'll rotate this view. Count, should I just do it clockwise? I think it's the same no matter what. It's going to be 2 clicks. Okay, 2 clicks and done. So all the pages are here. They're just askew. So we have example 2 using the same method, a house lighting for a theater. So what I want us to do, and Omar, this is good practice for you since you're kind of confused, and I'm not thinking that everyone else is on the same page either. I think it's probably us as a class, except maybe our mathematician friends. So we're looking at example 2. We have a house lighting for a theater. You're always going to have the area in order for this work out. If you don't have the area, you wouldn't be using this equation. So they gave us the area because we know it. So the area is 3,000 square feet. The average foot candle level required is 10. Where do I find that information? We refer back to the chart. So what am I looking for in the chart? I'm looking for what kind of area I have first. So up here it says lighting for a theater, house lighting for a theater. So I need to figure that out from the chart, what my watts per square foot are. So I go back to my chart, which is going to be in the Word document that I give you. So here's my chart. So I'm looking for house lighting for a theater. Oh, convenient in my chart, I have theaters, house lights in brackets. So in here I have watts per square foot is 1.0 at the greatest value. And then they also did the greatest value of foot candles, which was 10. So here's where they got the 10 from the chart. We're looking for our foot candles based on the use. So we have theaters with house lights, and that's 10 foot candles. And then we have to pay attention to the type of lights too. So there's another element maybe I didn't make clear. There's fluorescent, compact fluorescent, and HID lamps, but sometimes we might not be using those. We may, and this will be in your specs on if you're choosing an incandescent or a halogen. So here we're using halogen lamps, and in that case we're going to have the 1.0. Okay, so let's go back and look at our crazy PDF. So we saw where the 10 came from. We located in the chart the words house lighting for a theater, and that drew us to the foot candles being 10 at the greatest value. Although, Omar, what I'm saying was there was a range given, right? It said, let's say 7 to 10. For your homework, you're allowed to say it's, I picked 10, but really it could have been anywhere from 7 to 10 because there's a range. So they just chose that by themselves. That's something that they made the design, why am I losing my word today? They made the decision to choose that number. But it had to be in that range at least, okay? So 10 was the greatest, and that's probably the easiest way to think about it. The watts per square foot are 1.0. So now we have all this information starting from what type of space, the given area, and using our chart. And here's where it said the type of halogen, which helped us with our chart. So over here, we take the area and multiply it by our 1.0 watts per square foot, and that gives us 3,000 watts. And then we need to divide the wattage per fixture. So we take our 3,000, and over here is where it says halogen recessed downlight, either 60 or 100 watts. So here, if we have a range like that, we took 3,000 and divided by 60. If we choose the ones that are 60 watts, it would take 50 fixtures. If we choose the ones that are 100, it'll take 30 fixtures. If you're trying to figure it out, Omar, and that still doesn't make sense, then I think while this is good to re-show the math, I like the first example better because it shows us the words next to things as to why we're doing them. So multiply area by watts per square foot. That next example didn't spell things out as clearly. This tells you why you're doing it. Did that help you a little bit see how we're using the chart again, Omar? It could still be a no. If not, then I could help you outside of class or even in an email. Does anybody else have questions on it? All right, somewhat. I think trying it out would be good. If you, I think that there's another step. So maybe let's try doing the homework step to this, okay? So that way we have an example of the full homework step because it has less information in that you're choosing your own fixtures. In the book, they gave us our fixtures. So I'm going to scroll down to your homework question. So I don't necessarily want to do this. I'm going to create a new one for you, okay? And this is just on my screen for now. So here's A, and I had to pick us a area for you. So if I look at my areas, this is how I went about picking it. I want it to be on the chart for you guys. So let's say that we have a grocery store. All right, so that would have been given to you. I was functioning from the fact that you have a grocery store. And my grocery store is only 500 square feet. Little tiny grocery store, if you could call it that. All right. And then you provide the light fixture. So I decided I really liked, okay, so I Googled, first of all, why lighting over here. That was just a source that I had. Let's see how easy or hard this is to do. So lighting company Revit with Revit files. All right, that seems good, Google. I'm gonna click on that. Okay, so there's Eureka Lighting. Let's see what happens when we click on Eureka Lighting. They're now available. All right, products. So all the fixtures, indoor, outdoor, we definitely want indoor. Oh, look, they have light source options. So if you already know you want an LED, you could pick that. You want it dimmable. We want to have ours be ceiling surface mount, most likely. And I'm going to pick the ugly rectangle. It's not that bad, I guess, in the grand scheme of things. It's better than some of the troffers that I've experienced. So nice surface mount light. So here I'm using a surface mount light, but it works for our purposes. So let's see what information is given to us. 26 watt by 2 fluorescent double, triple, twin tube. So I'm taking this to mean that I have two 26 watt bulbs within my fixture. The spec sheet might clarify that and show me how many bulbs are inside, but for our purposes, let's say that is true. So I have a variety of options, it looks like a CFL spiral tube. So I'm going to start with this, and then you're going to highlight for me on your homework what you chose, okay? Or at least copy and paste this portion so I can find it, and then provide me with the spec sheet and the name of your light. So provide me with that and copy and paste this part into the tell me what you chose. So I chose this, Control C. I'm going to copy that. I'm going to go into my homework. I have a grocery store. I picked my light. It has 26 watt by 2 compact fluorescent double twin bulbs. Is compact fluorescent even an option on our, so we have compact fluorescent. All right, so that's gonna kind of tell me I'm in this category. I don't have a halogen lamp. So I have a grocery store. It's 50 to 100 foot candles. Because I want to be safe, I'm going to choose 100 foot candles. So it's 100 foot candles, and then it's 2.0 for my watts per square foot because I chose the highest value and the highest value. So 100 foot candles and 2.0 watts. 100 foot candles, 2.0 watts. All right. Okay. At what time does the lab open? What time am I here in lab, or just is lab open? I don't think so. I think I had it in the email, but not in the actual class session, like posted under information. I could, but are you asking for me specifically or just the lab open? Like any time that someone's, me or Cheryl? Oh, okay. Emily is saying that she'll be here Tuesday and Wednesday if anyone wants to work together to do the calculations. And then I can be here on Tuesdays in person if you just let me know via email that you want me here, or I can do it GoToMeeting. And then, and that's Tuesday from 12, well really, yeah, 12:30 all the way till 4. And then I'm also here Thursdays from about, well, I have class at 1:30. In between 3:30 to 7:30 is a time that I could help as well, so right before the class. And here, let me put mine in there. Tuesday, 12:30 to 4 o'clock. And then Thursday, 3:50 is when my class ends, to 7:30. Okay, so I put that in the chat for you, Madeline. And let me make sure no one else said something. Okay, Omar, okay, Emily already responded to Omar. So now we can go ahead and look back at our sample equation from the book. So we have our square footage here. We have the foot level required, right? That is our 100 foot candles in our case. 100. It's going to be lovely. We have 2.0 from the chart for this portion. We only have 500 for square feet. All right. So then from there, we need to go ahead and take our area and multiply it by our watts per square foot. So this is our area, the 500, and then our watts per square foot is the 2.0. So it's going to be 500 times 2.0. All right, I lost my little guy for you. And then that is going to give us our wattage for the overall space. So let's do that with our calculator, because really I should know that. I don't even do simple math like that, right? Is it 1,000? Is that what it's going to end up? All right. I just have no confidence in my math abilities after I messed something up in art the other day, so. And my 8th graders like, this is so wrong. We're not doing this activity until you fix it. All right, so we have 1,000 watts for the overall space. So on comparing it to this here, my new equation gave me 1,000. It's hard to draw with this little guy. Okay, and then we have a little bit of nuance similar to this, okay? So sure, we had that our light fixture over here is 26 watts, 26, but we have 2 per fixture. Well, that's pretty. Times 2. So we have to remember to do this step. That's different than the second example that I showed because there's 2 per each of those square fixtures. We have to incorporate that 2 part. So it's going to be 1,000 overall wattage divided by the, in brackets, 26 by 2, and then that'll give us our fixtures. 52, you say? All right, so Emily does math for us in the background, and it magically makes it all come out to be 52 fixtures. Oh, okay. I was like, that seems high. 36 times 2 is 52. Okay, so here's what she's saying is 52. Dun, 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 is this portion. So when we multiply out to the, actually 26 times 2, is that right? So, okay, is 52. And then 1,000 divided by 52 is going to be 1,000 divided by 52, about 19 and some change. So for our purposes, we know I'd rather have more than less, right, if I'm going up. So let's call it an even 20. You could tell me this amount is what you got and then say I put 20. And then the next step, if we were actually going to draw the space or had our existing core, would say, well, what's the best arrangement for those 20, giving the other things that I mentioned earlier. But we're not doing that step tonight for homework. We're just going to be doing the calculations. So I hope that that helps you a little bit to see how you're going to do it for your homework, okay? Clear as mud? Great. Let's go ahead and look at the last part, which I am not going to help you through. So these 2 things, and it's, well, not this one. This is the secret in-class assignment. You will really have these 2 problems. So it's worth 100 points. They're equal points. So this is 100 divided by 3. And the last one says, what are the other lighting calculation methods? Create your own parameters and show me how these methods work. They must be different than the examples in the book. Okay, so I'm not going to show you every method. This last one, I want you to take my devious little printout of these, and you'll see when we rotate them, view, rotate clockwise, view. We don't always, now remember, I said the good thing about this homework assignment, darn you view, I'm going to beat this thing to a pulp. All right. So the good thing about the homework assignment is I feel like for your final, we're only going to use the first one, but there are situations where you're going to have pieces of information missing or different things given, like you might have lumens instead of foot candles, and then we have to solve for the foot candles. But all the information is really here. I've given you 2/3 of your homework. I do want to see you trying to take this information given, right, and refer it back. It does still refers back to the chart on some level, so we'll have square footage might still be given. The type of room is still going to be given. You can refer to the chart, but we might not have the wattage. We might only have the lumen. So that information can be found in the same area, and then we just do our equations differently. So there is going to be a level of you trying to do it on your own. If you have issues with it outside of any instruction you get in a group, then you can definitely email me and we'll set up a time on either well, hopefully Tuesday for my lab hours. And that way it's not just right before class, because that's a little crazy. But it can be if we have to, if that's no other time works for you. And sometimes if you're like really stressing and Tuesdays during that time don't work for you, then you can just email me and I'll do a go-to meeting at a strange hour of the day, like 6 o'clock from home. That doesn't bother me. So let's see in the chat who I have. Anyone? Okay, thank you. Okay, so nothing new since we did the last chat. The next piece of your homework, let's go back to our website. So we have some calculations. There's only, I believe, 2 more types of equations you're doing. You need just one example of each of them. And you're setting up everything. You're choosing the room. You're then using the chart from that choice of the room to tell me the other 2 pieces of information, and you're choosing the fixtures. So you're basically acting as a teacher almost and saying, here's the parameters I set up, and then you're also acting as a student. But same thing I just did, where I choose some more information and give you most of the pieces and we work it out. So our writing assignment you saw is just continuation of the cheat sheet plan. I did provide you this idea of HVAC plan examples. So this is kind of a clear, it does okay. Now it's for a specific company, so you'll have pieces of this where it says, buy our software. And I'm not really interested in Concept Draw Pro, but the overall concepts are helpful, and it explains why certain symbols were chosen or why we have return, air, and then why we have diffusers. So this is not the type of information we have to ever provide for a HVAC plan. This is more on the engineering side, where they're dealing with the check valves, the testing points, and the valves. Completely different set of drawings than we have to be concerned with. For this, we don't have to concern ourselves with this either. There's little diagrams in the book that I think help you understand where we have return air registers, and I think I have good examples of them in the PowerPoint that I'm providing you with. So this is more of like a house situation or a non-commercial, sometimes some commercial spaces, older commercial spaces, but where we're dealing with returns more being around the perimeter of the room and towards the floor, maybe with flexible ductwork, and it could be between levels if we have multiple levels in our house, so that we have the flexible ductwork. We might have a sidewall register, the dampers in between controlling the valves, top takeoff, so baseboard registers, all these things, these are how we mostly see it in residential. The next picture gives us an idea. We don't always get to see exposed, and when we do, I think we're too distracted by how cool and industrial it is to really think about what's going on. So here we have our diffusers, and we can see here they're nicely and perfectly straight rows. When you do your visits to the sites that you're going to, they might not always be that way. So we do see sneaky, they might pop out to the side, have a bend in the vent, and then just come out randomly to the center of these 2. So they're still connected though, which I think we can see less dramatically and interesting layout, but here. So here we have our diffusers. They're the ones with the X through them. And then we have our returns. All right, so notice that the systems don't interact with each other. They're weaving over and around each other. And then notice from the screen too, like these are the quick and dirty details that I'm giving you right now, because your book does a great job at all the fancy stuff, but I want you to know what we actually have to do at the end of the day for the drawings. Okay, so this is what your drawing will look like minus the connections. So here's with the connections, and then notice the biggest thing about this. There's more of the diffusers, so they output into the actual rooms, than there is the return back in to circulate it back through. We have almost 2 to 3 times the amount of diffusers to returns. Okay, let's take a look at this website. what are we responsible for usually? What will look like? Not this. This is too much concern with the controls. Mostly things like this. So on top of where we might have light fixtures, sprinklers, um, exit signage, all types of things. But really those will be the main ones. We would also have each of those without all the pipes showing. We're not, or sorry, ducts showing. We're not concerned about that. We just want to see what cuts into our ceiling plenum, and we want to know how it relates to the other things that are being hung or cutting through the ceiling plenum. We can get into the differences between if you have a chandelier and whether it shows up on, but you should remember that from AutoCAD, right? Some of you. Some of you who had my AutoCAD. And those who did not, you will get a crash course in the beauty of laying out ceiling plans in AutoCAD. So we didn't do very much with HVAC, but we did do a lot with our lighting fixtures and the rules associated with that. So this is a good job here. This apartment HVAC plan shows the layout of exhaust ventilation duct outlet diffusers. Ventilation is the intentional introduction of outside air into a space. Ventilation is mainly used to control indoor air quality by diluting and displacing indoor pollutants. So it does a really good job at explaining why they have the layouts, what the different symbols are. And then, like I said, sometimes this is still kind of related to us. They're just using interesting choices of symbols. So we have rectangular inlet, linear return diffuser, and a grill diffuser. I think most importantly, this would be a good thing. You want to add it to your cheat sheet of all the symbols that you might want to use. I know if you plan on using Revit going forward, it's less useful because they'll pick them for you if you know if you're doing, cool air return, or if you're doing another type of grilled vent. So here, this is more for my AutoCAD friends and people doing it by hand where we don't have those tools available. You have clear labels for your symbols. And then here's just putting everything together, right? Luminaire that's ceiling mounted, enclosed ceiling luminaire, ceiling fan, multi-light bar, outdoor ceiling lighting, motofluorescent, circular outlet, a grill diffuser, and a linear outlet. So we have our lights being combined in with our HVAC details. And there's some things I'll take precedence with, like the fact that there's doors showing on this plan, but other than that, it's a good example of how we're combining the things. And as you'll learn in AutoCAD, the stringency of ideas like don't show your doors because they're not actually cutting into your plenum versus showing your doors. That all depends on the architects that you're working with when you get into the field. So we will look at some examples. Reviewing these things today, let's see if I have one of them open. So I can close Eureka. Oh, I thought this was interesting. I was trying to be you as a student and see how the whole Googling would get you, which it seemed to go okay as far as finding fixtures today with associated to Revit symbol. But in thinking about when you're going to count your ceiling tiles and information you might find on the layout of our HVAC, and I found this good little blurby. It's not like a super educational source, but it is true. And the book actually might mention it. I'm a little rusty. I read it last week. But bad duct placement. So the bad duct, they show a diagram of the door is right here. The bad duct placement is too close to the door, and that causes the air to circulate all the way out and just be lost. So it's not maintaining it in the room. A better duct placement might be back towards the corner. Now this is for a small size space, but we still have those kind of things that we're looking to focus on, such as door placement, the size of our windows, opportunities for air to be escaping through certain types of cracks and crevices, or possibly through the plenum if it's not covered correctly or insulated correctly. So just, you might find extra things like this. I'm telling you, your cheat sheet, just put it in a binder and save it for the rest of your life. There's things that you'll see them and you'll think, what great things for this semester, and you'll forget them by next semester. Oh, here's our, you'll forget them by tomorrow. Yes, Exactly. So here is HVAC exposed. I just wanted to include just a who's. Do you guys say house? Who's? House? 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 I don't know why. I don't use it very often, but I did find this article on exposed ductwork, and it shows it more often a residential setting, but still with the ceiling application. And it really can be a beautiful thing that doesn't have to be covered up. I like it when they painted it and integrated it in with all of the beams. It's pretty classy. No, it's kind of like a beautiful architectural feature in that one. They have extra added fans for air circulation. This is kind of cool where they streamlined it. And when I say streamline, I think about the Airstream when I look at this version of it. It might have a little bit of a brushed nickel quality to it. Sleek and minimalist. So it comes in a variety of shapes and sizes, and it depends on your application. Not bad. We've seen better, I think. And then sometimes you'll have the more flat ducts as opposed to the round ducts. And I think I showed that in the images here. So the difference between the two types of ductwork that you may see or encounter. And then here's just the idea of the outside compressor, that we have a coil and a fan that's blowing it through when we have forced air. And then we have the supply air duct here. We have supply air grills. And then we have a return duct. So sometimes these things are in the ceiling, sometimes they're in the floor. Cheryl was saying at Ivy Tech she doesn't know for sure, but it depends on the application and the codes. Sometimes the return duct doesn't even exist. Sometimes it just is a return up into the ceiling plenum, into the expanse of the ceiling plenum. So it's just going up. It's returning up, but not actually being forced into a duct system. So if you took off the ceiling tile, it might just be emptiness. So she said it depends on the code and how much they need to push that air back through, but it could be just enough that they're venting it up and out into the plenum. Okay. Let me make sure I touched on everything for our homework, because now we will be moving a lot more towards homework because homework is focusing towards our final. HVAC plan examples is that little website I gave you where they're trying to get us to buy their software. It's good. I think that really will give you a good idea. I think the most interesting thing will be the variety of answers. Oh, I did want to. Can I have some volunteers for today for the writing assignment? We were going to treat it like a discussion board in a way and have some of you share your images that you picked out of your best lighting experience and share them with the class. Anybody? Emily said she will if nobody else will. Oh, maybe it's in the chat and I'm just not scrolled down. Liz says she loves house. I'm like not confident about saying it. I think I'm supposed to love it. I just don't. Now that I teach, not that I'm outside the loop, but I think I just don't have time as much to explore those options. So I just stick with what I know. It's changing all the time. I need to get with the program. Like my 8th grade boys, I said something about Facebook and they said, "Oh, Mrs. Green, you're so old. Nobody has Facebook. That's for old people." And I said, "What do you have?" And they're like, "We have Twitter and Instagram, and we will never have Facebook." And I thought that was strange to think about. I'm sure Snapchat too, but the world is changing for sure. So, okay, Emily's going to share, and then I have to have another volunteer. I will just take what was turned in, and I will share it myself at random. She's going to find it. We're going to take a pause. And then the 17th of November, I think so, that day is going to be Cheryl coming in and giving a talk on LEED certification and everything LEED. And then I'm going to give you a review after she's done speaking on our book and the importance of what you've read to that. And we'll be finishing up the reading of the chapters that we skipped over. I know that's off in the distance. It feels like next week almost, but it's not. It's like a Tron PowerPoint. All right, so I'll share the screen with you. Sending my screen change presenter to Emily. Go Cubs go. All right, Emily, what you got?
All right, so I wasn't really sure as far as illumination experiences, what exactly you were expecting. So I decided to do Disney World
All right.
at Christmas time. And
Wait, Emily,
what?
can anyone else see Emily's screen? Because I am not seeing it. Did
You
you
can't
get my
see it?
invitation? Or do you want me to resend it?
Resend it.
Okay. Yep, Chrissy says she can't. Oh, no, I don't want to do that. So, it's weird when I try. Okay, I'll try again. Change presenter. It says you're the presenter. I'll change it to me. Show my screen, and then I'll change it back to you. Okay, I sent the invitation.
Okay.
Let's see if we can't get it to. Perfect.
Is it showing now?
Mm-hmm.
Okay. So I chose to do Disney World in December. When you go to Disney, everything there is lit up, and all of the parks and the hotels are decorated with a different theme. But I thought that Cinderella's Castle was a really good example. The way that they have lit it up, the architectural features of it are still really visible. So I included a picture of it lit up and then one when it's not lit up.
Mm-hmm.
And you can see how all of the shapes are accentuated. And it changes colors, which I thought was really awesome. And they do a fireworks show right there. So I thought that was fun.
Very nice. Anybody else want to share? Do you have continued slides?
I do, but why is it not changing? Now my screen won't do anything.
Not good.
No, it won't.
Madeline, then you have yours. Do you want to share it? Are you willing to share it? Even though you didn't submit it? Okay. Oh, wow. It's really all like that at night?
This is what they call the Osborne Family Spectacle of Lights, and it is in Hollywood Studios,
Oh.
and they have this whole section that is completely lit up, every little inch, and these pictures down here are like the little doorways of all these buildings, and you can see like even the bicycles, the wheels have lights on them. But then they're dancing lights, so they're set to music.
Oh, that's really cool.
Yeah, and I was going to include a video, a YouTube video of them going, but I couldn't find a really good one that didn't have like people talking and stuff. But the pictures don't even do it justice. Just massiveness of it. And then it's even more incredible because they have snow machines that blow in snow at the peak of the performance.
Wow. I wonder how they clean that all up after every time.
I don't know. And then I also thought about Fremont Street in Las Vegas. It is in Old Vegas, and it's about 4 to 5 blocks long, and the street has been turned into like a pedestrian walkway,
Uh-huh. This is cool.
and it has this big curved screen that stretches the whole length, and the displays change. And it also, sometimes they'll play music, and we'll have different light shows up there. And this is kind of what it looks like once you're inside. And all of the casinos and the shops and stuff that are all along there are all lit up just like they are on the Strip.
Very
So
cool.
it's really kind of a crazy feeling. And this one I included just because I think it's really, really pretty. The Golden Nugget. It's right there on Fremont Street, but it has a totally different look and feel than the rest.
Mm-hmm.
It was just really kind of a classic design. And in Old Vegas, they use more of the lights, those big bulb lights. I don't think you can really see them here, but it just is a different look than what they use now.
Mm-hmm. Very cool. Very neat. Yeah, it didn't have to be anything too stodgy. It could have been something like this. This is great. It didn't have to be really complex and overly thought out. It was meant to be the break of the assignments, if anything else. And the big part, even though it wasn't due this week, was to be working on your cheat sheets, which are more of our foundational things. So this was equivalent to a discussion board, but very well done. Okay, well, Madeline, I think we're at our time. Nobody go anywhere because I want to make sure I have everyone on here. So Chrissy, I want to add you to my list, and then I'll check my count because I think that puts me right where I need to be. Brianne, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and me makes 11. Okay, you are free to go. Thank you so much, guys. Yeah, maybe next time. That's fine.